Hi there. In this video I want to show you something about radio. I'm not sure if you have heard about it, but in some forums sometimes people think they are smart if they can broadcast on the so-called IF frequency from a radio, and the job is, people think, how can I jam a radio broadcast? And they think, if I broadcast on the so-called IF frequency, no matter what station the person tunes in on the dial, all the person on the radio will hear is my own transmitter. And I'm going to show you what happens if you do that. And I'll talk about radios in general. I try to keep it short because I'm having the 15 minutes upload limit and this is not really nice. So a radio basically works with these three components. I mean, there is much going on, but the for us important part. You could make a mark, or you could circle this in, because these three parts here form the so-called tuner. What the tuner does is, it takes any frequency from, for example, from the FM band, and along with the local oscillator and the mixer, it converts it down to 10.7 MHz. So you must think the radio as if there was a radio inside the radio, and the radio inside the radio is always tuned on 10.7 MHz. You can't change this. Like, someone has tuned it on 10.7, and no matter what you do, you can't untune the 10.7. So if you have a station on 100 MHz, you will have your local oscillator on 110.7, and along with these two frequencies, the mixer makes 10.7, which the radio will then receive and convert into music, speech, or whatever you want to listen to. I'll show you this practically. Here I have set up my radio, and I have set up a small FM transmitter, which is licensed here in Germany, or around Europe, I guess. It's very weak, goes like 10 feet or so. But anyhow, I'm on 100 MHz, and I'll tune it in. First I need to turn on the radio. Here we go. So you can hear it. So you can hear it works. And here I have a very expensive and fancy communications receiver, which can receive 10.7 MHz. And now look what happens. I'll turn back on the radio. I'll decrease the volume to 0 so the radio stays silent. And I increase the volume on this receiver, so you hear static. And now let me place it here. And now I hold the radio back from the radio to the antenna from this receiver. And if I find the right spot, well, in the static, but there you go. So you can see that the radio is indeed converting my FM transmitter signal to 10.7. If I turn off the radio, it's gone. If I turn back on the radio, so you can see it does convert the FM transmitter to 10.7. Now let's take another radio. This one here is a rather modern radio, and it's also tuned to 100 MHz. And if I turn up the volume, you can hear the music. Now decrease the volume, turn up the volume on my receiver again, and place the radio on the antenna for my receiver. Along with some buzzing, because I have some QRM here, and you basically should be able to hear it. The cassette's over. So you can hear it. It's in the noise. I'm sorry that it's that noisy, but this buzzing you hear is my QRM. But you can hear it. And if I turn off the radio, it's gone. If I turn it back on, it's there again. And now I'll show you something else. As I said before, the local oscillator is 10.7 MHz above. So here we have 100 MHz from the antenna, and here we have the local oscillator, which should be on 110.7. 110.7. Here we go, we have a signal, and of course the signal is quiet. There's nothing on there. And if I turn off the radio, there is still a signal because there is this radio, and if I turn off this radio also, you can see it's gone. So turn back on the radio, which is on 100 MHz, does generate a signal, and depending on which station I tune, the signal will be different. Now let's tune in a different station. There is a new station on 105.7. So let's tune in the news station. It should be around here.
Erfreulich aus deutscher Sicht, Christina Geiger kam im ersten Lauf als 7. ins Ziel. Um 14:30 Uhr beginnt der zweite Durchgang. Und morgen beenden dann die Männer mit ihrem Slalom.
So that's the news station. Now if we look for the local oscillator, I have to add 5, so we are on 115. 116, we should be somewhere around here. I'm not good at calculating stuff in my head. So we need to add 5.7. So we were on 110.7 plus 5 would be 115.7 plus should be 116.4. Ah, we have a signal. It's just not very strong. But yeah, it's really not how I like this video to be made, but at least I'm making it. So you can see, if I change the local oscillator, if I change the station, the local oscillator frequency will change. But now let me check something. If I put in 10.7, 10.7, and hold it to the radio, you can hear it. So no matter what I tune in, I will be able to change the frequency from the local oscillator, but no matter what I tune in, it will always be 10.7, which is the radio internally receiving. So as I said, the smart guys say, why don't you go ahead and just broadcast on 10.7? You could just override or overlay all other transmissions, and all that the radio will pick up is your own transmission. And in this video I'm going to test this and show you that it does work, but it does not really work. Also, before I go there, a few mentionings. On AM you can do exactly, you have the same circuit here. On AM you have the same circuit, but it's not 10.7, it's 455. And I will show you what happens if you broadcast on 10.7, and I will show you what happens if you broadcast on 455. Also, today's radio use a digital signal processor. On today's radio, this trick won't work. It will work on the rather 80s radios. This one's maybe even 80s, 90s, it will work on this, it will work on this. It will work on my CD radio, but it won't work on a today's DSP radio, like Modern Car Radio, or there are some receivers, I think Tescon, is that how the company is called, or Texan, or however. They make receivers using DSP, and you probably can't make this. And the other side is the low price area, so this is a rather really cheap radio, and it uses a TDA 7000. Maybe not exactly the TDA 7000, it probably uses a surface mount device chip, but it has a similar internal circuit like the TDA 7000. And unlike these usual radios, which use a 10.7 MHz IF, the TDA 7000 chip works different. So you will see that you can't really manipulate this radio except you are overlaying the actual broadcast. So here is the news station turned in. So that's the news station, and now if I turn on my receiver, and you can see nothing. So you could see that there is nothing, I cannot receive anything. So let's check the local oscillator. It would be 116.4. There is still a signal, but don't get fooled, that's this radio. Turn it off. Nothing. So as you can see, these radios work different. And now let's just see what happens if I apply a 10.7 MHz signal close to a radio, and therefore I have to pause the video and be right back. So here I'm back now. This is a 2-circuit. Here I have a 10.7 MHz FM transmitter, so it does generate 10.7 MHz. I guess it's 30, 40, 50 milliwatts RF output. So I have an oscillator which is already quite strong by the values I choose, and then I have an amplifier put on it. And here on the other side I have a 455 kilohertz transmitter. It's maybe a 50, 100 milliwatts range. Not really strong, but what I want to do is I have this antenna wire, which is a little bit longer than 1 feet or 1 foot. And the 1 foot long antenna wire does generate, around close to it, it does generate a very strong RF field. And it would be the same as if you have an antenna on your roof and go like 4 to 5 watts RF power on the antenna on your roof. This would be probably, what this generates is the same signal as the other antenna would generate in, say, 50, 100, 200 feet over your building. So I can make it like symbolic experiment. Okay, so let's turn on the receiver and see, here is my transmitter. I'll turn it on. And you can see we have a very strong signal. And now let's just test it with a radio. So here's my radio. I'm turning it on. New station. Now let's turn on the transmitter. See, it overlaps. So you can block the broadcast. I'm not blocking the actual broadcast from the news station. I'm just blocking this radio. And no matter what station I tune in, so you can see it, it will always only receive your station, no matter what you tune in. So this is like 30, 40 milliwatts, let's say something in that area. Let's see how far it goes. So the antenna is well matched. See? It does not go far. Maybe 10 inch. So 10 inch or 25 centimeters is pretty much the maximum range you can get out of this. Because also, if you tune in another station which is very strong, it will overlay your transmitter. Let's try a different radio, because I have many other radios. So let's try this one. I said you, this one won't be affected.
Zum Beispiel über Ehepartnerin oder Partner gut versorgt sei oder geerbt habe, sondern nicht einfach so eine Grundrente
See, it doesn't care. I even can touch it.
Sicherung und Rente solle man nicht vermischen.
So as you can see, not every radio works. And now let's try this one. This is the radio modem.
Existenzminimum decken, falls die Rente nicht reicht. Bundesarbeitsminister Heil.
Let's tune in a free frequency. Let's tune in a free frequency, let's say 104.5. Okay. It basically is working, but for some reason there's no audio. Basically you would hear the music now, but there's somewhere contact going off or anything, or something. But it does work. Basically you would hear in every... here we go. So no matter what I tune in, but as you can see also here, the range is not really good. See, that's the distance. So it doesn't matter what I tune in, but if there is a strong station,
Damit ändert sich auch die
the strong station wins. So this is broadcasting directly in the IF of a radio. So I can tune in any frequency. I can go in like 87.5. So you see, it always overlaps this. So we tested it with FM. So this is, as I said, 30, 40, 50 milliwatts FM transmitter on 10.7 megahertz. How about 455 kilohertz? So I will show you that, but therefore I will pause the video again. So here we are back again. Now I have tuned in, it's on shortwave. Shortwave, and I'm somewhere here at 15.3 megahertz, and I hear a station. So I have not turned on my transmitter, so now I turn on the transmitter here. See? It overlaps it, no matter what I tune in. It just overrides all other stations. Let's go to a different band. It doesn't matter. I can go to long wave. I can go to AM. Well, there is some QRM, but basically it's overwriting it. So no matter what I tune in, I'll show you this with a different radio. But this one here you may remember from before. So no matter what I tune in, see, I can tune whatever I want. But the range is not too good, see? So basically, overwriting a radio with a strong signal on the radio's internal IF frequency does work. But what I want to state, or what I want to show with this video, you need a tremendous amount of RF power to override it. If I actually would boost the circuit with some better components, or better for this operation components, and go to 3, 4, 5 watts, I may be able to override radios in 1 or 2 rooms. But this is no effort worth doing it. So I hope this helped this video. Best regards, Stefan.